We're analyzing something remarkable that might be unfolding with 3-eye Atlas. Multiple independent observatories are reporting velocity changes that appear inconsistent with natural trajectory patterns. When an object enters our solar system on what we call a hyperbolic orbit, the physics are straightforward. The object carries excess velocity beyond what's needed to escape the sun's gravitational influence. After a perihelion passage, it should continue outward, returning to interstellar space. That's the expected behavior based on celestial mechanics we've understood for centuries. But 3-eye Atlas appears to be deviating from this expected path. Before I continue, I need you to engage with this analysis. Tell me which country you're watching from. Drop a comment, like this video, and subscribe to this channel. This helps us understand the global reach of these observations. And here's a direct question. Do you believe interstellar objects could be technological in nature? Write yes or no in the comments. The trajectory calculations from JPL show something that demands explanation. Over approximately 11 days, the object's velocity relative to the Sun appears to have decreased by roughly 2.8 kilometers per second. Now, measurement uncertainty exists in all astronomical observations. We must account for potential errors in our data collection methods. However, when multiple independent facilities report similar findings, the probability of systematic error decreases significantly. If this deceleration continues at the observed rate, the mathematical implications are clear. 3-eye Atlas might establish permanent residence within our solar system. The velocity imbalance are striking. 11 days ago, tracking data suggested excess velocity of approximately 4.2 kilometers per second. 8 days ago, that figure appeared to drop to 3.1. 5 days later, 1.9. Current data indicates roughly 1.4 kilometers per second. If this trend persists, we're looking at zero excess velocity in approximately 18 days from now. Zero excess velocity means the object becomes gravitationally bound to the Sun.
It would no longer possess sufficient speed to escape. From a physics perspective, that represents a fundamental change in orbital classification. But here's what concerns me most as a scientist. The projected orbit parameters suggest something even more specific. Based on current deceleration profiles, the resulting elliptical orbit would have an aphelion around 1.5 astronomical units and perihelion near 0.9 AU. For context, Earth orbits at approximately 1 astronomical unit from the Sun. This means the projected orbit crosses Earth's orbital distance. More significantly, the orbital period might establish what we call near resonance with Earth's orbit. The object would encounter our planet's vicinity repeatedly on a predictable schedule. Now, let me be clear about the scientific method here. We're observing a phenomenon. We are calculating trajectories based on available data. We're projecting possible outcomes. What we cannot yet determine with certainty is the mechanism causing this deceleration. Natural processes could potentially explain velocity changes. Solar radiation pressure, outgassing from volatile materials, gravitational perturbations from planetary encounters. These are all possibilities that require thorough investigation. But the sustained nature of this apparent braking raises questions. The energy requirements for such velocity changes are substantial. If this is active propulsion rather than passive effects, we are looking at technology operating on principles that exceed our current engineering capabilities. Let me walk you through why this capability represents something extraordinary from an engineering perspective. The delta V required here, the total velocity change needed to transition from hyperbolic escape trajectory to bound orbit involves removing approximately 4 kilometers per second of velocity. To put that in context, the Apollo missions required roughly 3 kilometers per second of delta 5 to escape Earth's gravity and reach the Moon. What we are potentially observing with 3I Atlas exceeds that, and it's happening continuously over weeks rather than in short burns. If we're looking at nuclear propulsion or some exotic system we don't currently understand, the engineering sophistications would be far beyond our present capabilities. Either scenario suggests intentional, controlled modification of trajectory for specific purposes. The timing matters significantly. The apparent deceleration began shortly after 3I Atlas completed its closest approach to Earth at 0.885 astronomical units. During that pass, any observing system aboard the object would have gathered detailed data about our planet: electromagnetic signatures, satellite presence, industrial activity, urban development patterns. All of this would be apparent from external observation. Then, immediately following that close approach, the braking behavior begins. The temporal correlation doesn't prove causation, but it does suggest a hypothesis worth investigating. What if the decision to decelerate was informed by what was observed during that Earth flyby? Consider what external observers would detect about our civilization. We are clearly technological. Radio emissions, organized satellite constellations, evidence of large-scale energy use. But we are also clearly early stage in terms of space capability. We maintain presence in low Earth orbit, but haven't established permanent settlements beyond our planet. We're also observably divided, multiple competing nations rather than unified planetary governance. All of this information would be apparent from careful external observation.
Yes, from an anthropological perspective, this represents a fascinating moment in civilization development. We are advanced enough to be clearly technological, but not yet mature enough to be stable spacefaring civilization. If you are studying intelligent life across the galaxy, this is precisely the developmental stage that warrants close attention. Or perhaps what was observed raised concerns rather than curiosity. Nuclear weapons, environmental degradation, geopolitical tensions. These patterns might trigger protocols for monitoring potentially problematic developing civilizations. I'm not claiming to know which interpretation is correct. I'm outlining the hypothesis space based on available observations. The detection methods we're using show no visible exhaust plume. No large thermal signature consistent with rocket engines. No evidence of mass being expelled in forms we can't detect. Yet the velocity changes appear real and sustained. Whatever propulsion system might be operating uses principles we don't observe in our technology. That alone represents revolutionary physics. But in the current context, it's simply another data point indicating how limited our understanding might be. The question we face isn't just what the 3 Atlas is doing, it's why. And that's where we are approaching something critically important. Why would an interstellar object choose to remain near Earth rather than continue its journey? This question has no definitive answer yet, but we can construct reasonable hypotheses based on what we do in similar circumstances. Consider the first possibility: extended observation mission. If the object came to study our solar system, and specifically Earth, remaining in orbit provides ongoing observational capability rather than a single flyby. This is exactly what we do if we sent a probe to another star system and discovered an interesting planet. We'd stay and study rather than pass through once and leave. Second hypothesis: establishing a communication relay or monitoring station. If 3 Atlas is part of a larger network, if it reports back to some distant civilization, maintaining position near an interesting discovery makes strategic sense. A technological civilization like ours represents significant finding worth monitoring long-term. The object could serve as permanent observation post, communication node, or data collection platform.
From this perspective, staying isn't unusual. It's simply logical mission architecture. Third possibility: pre-contingency positioning. If eventual communication or interaction with humanity is planned at some future point, having a probe in stable orbit nearby provides immediate presence when that contact is initiated. Rather than sending another mission that takes decades or centuries to arrive, the probe is already positioned and ready. This suggests patience, a willingness to wait for the right developmental moment in our civilization's progress before revealing its purpose or initiating dialogue. Fourth hypothesis: more concerning, strategic positioning for monitoring a potentially problematic civilization. If assessment of humanity raises concerns about our development trajectory, our behavior patterns, our potential to become a threat, maintaining close presence provides capability to respond to future situations. I'm not suggesting hostile intent, but monitoring a civilization that possesses nuclear weapons, demonstrates territorial conflicts, and shows signs of environmental mismanagement might be considered prudent from an external perspective. Fifth possibility: most significant, preliminary positioning before more direct interaction. If staying represents the first step in a plan that involves additional probes, expanded physical presence, or direct intervention in Earth affairs, then orbital insertion would be the logical opening move. You establish presence, you observe responses, you assess readiness, then you proceed with subsequent phases based on that assessment. The challenge we face is distinguishing between these possibilities with available information. We can observe what 3IL Atlas appears to be doing. We can measure the deceleration. We can calculate the projected orbit, but we cannot determine intent. We cannot access the decision-making process behind these actions. We're watching something with apparently superior capabilities make choices that directly affect us, and we're essentially powerless to influence those choices or fully understand them. This powerlessness represents the core issue that concerns space agencies worldwide, and it's about to get more complicated. When this object actually enters bound orbit raises questions we are profoundly unprepared to answer. Another important problem is NASA and other space agencies face a problem with no precedent and no clear protocol. If 3II Atlas establishes permanent orbit near Earth, it becomes uncontrolled presence in our space. It can observe all our activities continuously: satellite operations, spacecraft launches, military exercises, communications infrastructure. Everything becomes visible to whatever observational capabilities the object possesses. More significantly, it could potentially deploy additional assets, smaller probes, sensor packages, capabilities we can't currently imagine. And there's essentially nothing we could do to prevent any of that.
Some have suggested attempting more forceful communication, powerful radio transmissions directed at the object, requesting it to leave or explain its intentions. But consider the leverage problem. We can ask, certainly, but we cannot compel if it chooses to stay despite our request. We've accomplished nothing except demonstrating our lack of control over the situation. Others argue for demonstration of capability, showing we have defensive systems, weapons, technological sophistication, the theory being that this might discourage unwanted presence. But realistically, any civilization capable of interstellar travel isn't likely to be impressed or intimidated by our chemical rockets and nuclear weapons. The technology gap is simply too much. International coordination adds another layer of complexity. Every space-capable nation is tracking this object. Russia, China, European nations, India, Japan, all reaching similar conclusions about the trajectory changes. But national interests create tension in response coordination. Some nations see potential opportunity if contact eventually leads to technology transfer. Others see potential threat requiring defensive preparation. Unity becomes difficult when both fear and ambition run high simultaneously. If China possesses additional information about the object's systems or capabilities, that creates information asymmetry. Other nations work with incomplete picture, while one potentially knows more. This is frustrating from a coordination perspective, but consistent with historical patterns of nations protecting strategic information advantages. The information communication challenge may be the most difficult aspect. How do you inform people that an object of a known origin, with apparently superior technology, has decided to establish permanent presence near Earth, and our ability to influence this situation is essentially zero? NASA's approach so far has been releasing trajectory data without explicitly stating the implications. Technical announcements about continued observation without saying directly that it might be braking to stay. This strategy buys time for internal planning and international coordination, but it cannot last indefinitely. Amateur astronomers are tracking 3I Atlas. Independent researchers are calculating trajectories. The deceleration is becoming obvious to anyone doing careful analysis. Within days or weeks, the conclusion will become unavoidable and public. And that's when everything changes. Stay with me, because what I'm about to explain about the timeline ahead will show you exactly how close we are to a fundamentally different reality. Here's what makes this situation critically urgent. 3I Atlas will reach zero excess velocity in approximately 18 days from current measurements. Let me be precise about what that transition means. Zero excess velocity indicates the object no longer possesses sufficient speed to escape the sun's gravitational influence.
It becomes gravitationally bound. The hyperbolic trajectory that would carry it back to interstellar space transforms into an elliptical orbit that keeps it here. This isn't just any bound orbit. It's an orbit that crosses Earth's orbital distance repeatedly. More significantly, the timing and phasing suggest potential orbital resonance with Earth. The object would encounter our planet's vicinity on a regular, predictable schedule. NASA has run these projections extensively. Different assumptions, different error margins, different computational methods. Every simulation that assumes continued deceleration at observed rates produces the same basic outcome: orbital capture within Earth's vicinity. The Jet Propulsion Laboratory doesn't make casual errors in orbital mechanics. These calculations represent decades of refined expertise in trajectory analysis. If their projections converge on this scenario, we need to take it seriously. Now, what does it actually mean? If 3 Atlas stays from a purely observational standpoint, we transition from temporary visitor to permanent presence. Every space mission we launch happens under observation. Every satellite we deploy gets monitored. Every technological development we achieve becomes witnessed and cataloged. We are under perpetual surveillance in our own orbital space. That's psychologically significant, even if not materially threatening. How humanity has operated under the assumption that space beyond our planet is our domain to explore and utilize as our capabilities grow. Permanent presence of vastly superior technology redefines that relationship fundamentally. We're not explorers discovering empty frontier. We're junior civilization being monitored by senior civilization. That's a profound shift in self-understanding. But there's something deeper here that needs to be said directly. The fear that some people experience when contemplating this scenario, the concern about hostile intent, the worry about invasion or attack. Let me address that as clearly as I can based on the evidence. Advanced civilization capable of crossing interstellar distances possesses technological capabilities far beyond ours. If hostile intent existed, if we were merely resources to be exploited or obstacles to be removed, they wouldn't need to position carefully and observe for months. They would simply act. The fact that their behavior appears cautious, observational, and apparently responsive to what's being learned about us suggests something different. This is how you approach a civilization you are evaluating for possible communication or interaction, not how you approach a target. The carefulness is actually an encouraging sign, even though the situation creates anxiety. However, we need to be realistic about what comes next. If 3 Atlas enters bound orbit and remains, several questions become urgent. Does it eventually attempt communication? Does it simply observe indefinitely? Does it serve as relay that invites others to come? Does it wait for us to reach some developmental threshold before revealing its purposes? We don't know. And not knowing creates compound anxiety over time. My recommendation, based on decades of thinking about these questions, is measured engagement combined with realistic assessment of our capabilities. We should attempt communication, but not desperately. Send clear signals that we are aware of its presence, we're intelligent, we're interested in dialogue, but maintain scientific dignity. Simultaneously, we need to improve our space situational awareness, track it precisely, monitor for any additional objects or activities, prepare contingencies if the situation evolves in unexpected directions, be open to possibilities, but not naive about unknowns. What we are potentially witnessing is the end of humanity's cosmic isolation. For all of recorded history, we've operated under the assumption that we're alone, that the cosmos is empty of other intelligences, that we're the only conscious observers in our corner of the universe. If 3 Atlas stays, that assumption ends. We'll be living in a solar system that contains permanent presence of advanced extrasolar technology. That's simply a different reality than the one we have inhabited for our entire existence as a species. The countdown is active. 18 days until the mathematics resolves. 18 days until we know if we're still alone or if we're sharing our cosmic neighborhood with something vastly more advanced. 18 days until temporary mystery potentially becomes permanent condition of Han space operations. We'll be watching, calculating, preparing for the possibility that 3 Atlas just became Earth's permanent neighbor. And whatever comes next, we face it with as much wisdom and scientific rigor as we can bring to bear.